Hello everyone, I hope you're doing well today. Today we're going to learn how to complete the square. Is this picture a square? What about this one? Okay. What makes the first picture square and why is the second picture not a square? Well, the first picture is a square because we have 4 sides of equal length and 4 90-degree angles. The second picture is not a square because we have more than 4 90-degree angles and more than 4 sides, and the sides are not all of equal length. Well, what would we need to do to make this shape a square? Well, it's missing this little piece right in here. We would have to add a piece in right here to complete that square. We're going to be looking at some different polynomial expressions and learning what exactly it is that we would have to add to each shape to make it a perfect square. Before we do that though, I want to review factoring. So let's factor x squared plus 4x plus 4. Well, I notice it's a trinomial, so I can use my diamond method. Remember, the top part of the diamond is the quantity of a times the quantity of c. A is the leading coefficient in front of the x squared term, so in this case 1, and c is the constant term, our last term 4. 1 times 4 is 4. The bottom part of my x is the value of b, which is the coefficient of our middle term, 4. So I want numbers that multiply to 4 and add to 4. That would be 2 and 2. Now I would use my area model to factor this. Remember, the top left square is our first term, x squared, and the bottom right square is our constant term, 4. The other two boxes are filled in with 2x and 2x, the two numbers that we found in our diamond. Now I'd look for my greatest common factor amongst each vertical and horizontal pair of numbers. Between x squared and 2x, the greatest common factor is x. Between 2x and 4, the greatest common factor is 2. Between x squared and 2x, again, the greatest common factor is x, and between 2x and 4 is 2. So this polynomial factors into the quantity of x plus 2 times quantity of x plus 2. Well, since these are both the same, I can rewrite it as one single polynomial of x plus 2 squared. Now, what would that look like with our algebra tiles? Let's take a peek. If we notice, it looks, using algebra tiles, we notice we have the 1x squared to start with, the 4x tiles, and the 4 1s. If we look at the model here with the algebra tiles, we'll notice that across the top I have a length of x plus 2, and along the side I also have a length of x plus 2. The side lengths are the same, therefore it is a perfect square. Let's close the inspector. Now let's take a look at a few binomial expressions and use the algebra tiles to complete the square. Let's start off with x squared plus 6x. So I need one x squared tile and 6 of the x tiles. Since I want it to be a square, I'm only going to build off of 2 sides of my square in order to keep the side lengths equal. So I'm going to pull down 6x squares. As I do that, notice I end up with 3 x's on one side of the square and 3 x's on the bottom of the square. Now I need to figure out what I need to add in to fill in this square here. So I'm going to add 1s until my square is complete. Okay, now that my square is complete, I noticed that I had to add in 9 ones. So to complete my square, I would have to add 9 to my expression. Now that my square is complete, I need to look at the side length. Well, down here at the bottom, I have 1x and 3 ones. So that side length is x plus 3. Now looking over here on my side, I see that I have 1x and 3 ones, so the side length again is x plus 3. Since all 4 of my side lengths are equal, I know that I have a perfect square. So I would have to add 9 to complete my square, and then my square would factor into x plus 3 squared. Now let's try taking a look at another example together. Let's look at the polynomial expression of x squared plus 10x. I'm going to start off by taking the tiles I need to build x squared plus 10x. Remember, I'm only going to build off of the right-hand side and bottom of the square. Every time I add an x tile to the right-hand side of the square, I'm also going to add one to the bottom of the square as well. And I'm going to continue doing this process until I have a total of 10 x's. Now that I have my 10 x's, I'm going to fill it in with ones until I have a perfect square. Now that I've completed my square, I'm going to count how many ones I had to add. Well, I notice I've got 5 across and 5 going up and down for a total of 25, which means that in order to complete the square, I would need to add 25 to the expression x squared plus 10x. Now, if I wanted to factor it, I can look at the side lengths of my square. Down across the bottom, I have a length of x plus 5, and across the sides, I also have a length of x plus 5. Therefore, my expression factors into x plus 5 squared. Well, now how did we get the 3 and the 5 when we factored both of these expressions? If you notice, the first thing we did is we took that middle coefficient and split it in half on both of these. So when I split 6 in half, I got 3. Well, now how do I get from 3 to 9? Well, I have to square it, and 3 squared gives me 9. If I do the same thing on the second example, if I take 10 and half it, I get 5. If I square 5, I get 25. So in order to complete the square, we take the coefficient of our term in front of x, half it, and then square that result. Please take a moment to pause this video, write down these 2 examples, and also what we discussed about halving the coefficient and squaring it. Before we wrap up our lesson on completing the square and factoring, let's look at a few examples without building out our area model. Remember, we said we were going to take our coefficient in front of the x term and half it and then square it to figure out what we need to add. So looking at the example of x squared plus 18x, I'm going to take my 18 and half it to get 9, and then I'm going to square 9. 9 squared is 81, which means in order to make a perfect square trinomial, I need to add 81 onto the end of my binomial. When I factor it, I'm going to end up with x plus 9 squared. Well, we saw that 9 appear earlier on in our process. The value that we get whenever we half our coefficient is always going to be what is the second term in our perfect square binomial. Now let's look at the example of x squared minus 8x. Again, I'm going to take my coefficient in front of x, negative 8, and half it and then square that result. Half of negative 8 is negative 4, and negative 4 squared is 16, which means that I need to add 16 onto the end of my binomial. When I factor it, it's going to be x minus 4 squared. Remember, the negative 4 that we get here comes from the negative 4 up here. Finally, let's look at one more example together. X squared minus 3x. This one's a little bit trickier because we have an odd number, but our process is still the same. I'm going to take negative 3 and half it, and then I'm going to square that result. Well, I would leave this as a fraction, so when I multiply negative 3 over 2 by negative 3 over 2, I get 9 over 4. So that means that I have to add 9/4 to my binomial. Now when I factor it, it's going to be x minus 3 over 2 squared. Remember again, this 3 over 2 that we get in our perfect square binomial is the same as the 3 over 2 that we had up here. Take a moment now to pause this video, record these examples, and write down any questions that you may have. Take care, be well, stay safe, and I'll see you in our Zoom meeting shortly.